So this is stoichiometry using the ratio method or the proportion method. So I want to show you how to do this if you're having some trouble with the regular dimensional analysis stoichiometry method. So the first thing that we have to start with is our balanced equation. Okay, we always start with a balanced equation. If you're not given a balanced equation, you need to write one and then balance it. But in this case, we're given a balanced equation. We're going to start with something simple just so that we have something to work with. And we need to write down everything that we know about this balanced equation. So we're going to make a line for moles, okay? Now, the moles come directly from the coefficients in the equation. So here is 2, and O2 is just 1 because if there's nothing there, it's an understood 1. And H2O, we have 2. Okay, so now we need our molar mass, and that is, H, if you look it up in the periodic table, is 1.01. So 2 of those is 2.02. Pretty easy. O2 is just going to be 32.00, and H2O we know is 18.02. Okay? So now we're going to say we have the total grams. And this is going to become very important in our stoichiometry problems. So we're going to multiply this, and we're going to get 2 times 2.02 is 4.04 grams. 1 times 32 is 32.00 grams, and our 2 times 18.02 is 36.04 grams. Now you'll notice that it works pretty well with the law of conservation of mass because we have our 4.04 plus our 32 equals our 36.04. So everything should equal. If it doesn't equal, you've done something wrong. Okay, so that's a good check. All right, so now let's try a stoichiometry problem with this. We'll start with something very simple. We'll do a mole to mole ratio. How many moles of O2 will be reacted if 37 moles of H2 are reacted? So we're looking for moles of O2, and we have moles of H2. Okay, so the way we're going to set up our proportions is we're going to say the moles of O2 that we're looking for is X moles of O2. And the moles of H2 that we have, we're going to put in the denominator, 37 moles of H2. Okay, so now we're going to set this equal. Now it's important to remember that everything here comes from the problem itself, okay? This comes from the problem. So moles of O2 and 37 moles of H2. Now, the other side is going to come from the equation and all the information that we've gotten from the equation. So we have to keep the same units on both sides. Moles of O2 over here over moles of H2 over here. We're just going to look at our mole row here because we're just doing moles to moles. So we have 1 mole of O2 goes here, and 2 moles of H2 go here. And now if you remember from basic math, we just do cross multiply. Okay, we set them equal. So we have 2x equals 37 times 1. And if you solve for x, you get 18.5. Now, what are the units of this? 18.5? It's going to be what you're solving for x, moles of O2. Okay, so that's just the way you do it. You solve for x, we set 37 times 1 to 2 times x. And then you just divide both sides by 2 to get rid of the 2 here. And then you end up with 18.5 moles of O2. So let's try another one that's a little bit more complicated, okay? So this one is grams to moles, or moles to grams, depending on which way you look at it. How many grams of H2O are going to be formed from the reaction of 22 moles of O2? So we're going to set our grams of H2O to X grams of H2O, to 22 moles of O2. All right, so that's pretty simple. This all comes from the problem itself. X grams of H2O to 22 moles of O2. Now, if you put it upside down and you put the X at the bottom and the 22 at the top, it doesn't matter at all as long as you have the units right. Okay, so we're going to set this equal to, we need to keep our grams of H2O over here and our moles of O2 over here. So now our grams of H2O is going to come from our grams line in our equation. So we had our total grams was 36.04 grams of H2O. And our moles of O2 is going to come from our moles line of our equation. So that's just 1 mole of O2, right? 1. All right, so we do 1 times X, which is just X, equals our 36.04 times our 22. So we end up with X equals 793, and our units are grams of H2O. Okay, so that should be the answer to our stoichiometry problem. X equals 793 grams of H2O if we react 22 moles of oxygen. Okay, so it doesn't matter if you have grams or moles or moles or moles or grams. It doesn't matter with this method at all. You just put the unknown up here and what you know down here. And then this side all comes from the reaction. You just match the units up. Let's do another one, okay? This one is a gram to gram problem. How many grams of H2 will react with 472 grams of O2? Okay, so we're going to say X grams of H2, and we're going to put it over 472 grams of O2, and we're going to set that equal to, now we need our grams of H2 here, and our grams of O2 here. I think you're seeing a pattern now, right? So our grams of H2 is going to come from our grams line here, and grams of H2 was 4.04. Now our grams of O2 is 32.00. Okay, so we set this equal. 32.00 times X equals 472 times 4.04 on this side. All right, so if we solve for X, we multiply these out and divide by 32, then X equals 60.0 grams of H2. We know that the units are grams of H2 because that's what our X was. We just cross multiply and we solve for X, 60.0 grams of H2. All right, I hope this makes sense so far. We're going to go to another reaction that is very common. And this other reaction is going to just be a pretty common one that you see all the time. We've used it in class. All right, so we have propane. That's C3H8. That's the propane that you use in your grill, okay? And oxygen, and we have carbon dioxide and water. So again, we're going to start with our moles. And our moles here are 1, 5, 3, and 4. They come directly from the coefficients of the balanced chemical equation. Then we have our molar mass. And our molar mass of propane is going to be 44.1. And you'll see that if you add up 3 of the carbons and 8 of the hydrogens. Okay? Oxygen is 32.00. CO2 is 44.0. And H2O is 18.02. So we're going to multiply each of these out. Okay? 1 times 44.1. This is our total grams. Okay, this is our grams column that's going to be important. So we have 44.1 grams here. We have 32 times 5. That is 160 grams here. 44 times 3 is 132 grams here. And then 18.02 times 4 is 72.08 grams of water. Now, let's look at a problem. And I apologize for this problem in advance because I forgot to put grams of. But how many grams of oxygen would be used up with the reaction of 102 grams of propane? So we're going to set our grams of oxygen to X, grams of O2, and we're going to say 102 grams of C3H8. Now that equals our grams of O2 from the reaction, which is 160. 160.0 grams of O2. Now we need our grams of propane, which is just 44.1. Okay, so we take our 44.1 times X equals 160.0 times 102. And we get X equals 370 grams of O2. All right, so 370 grams of oxygen is going to be used up with the reaction of 102 grams of propane. So that's our answer. Okay, so this is a very simple way to do things. One last one that we're going to try. What is the theoretical yield of H2O if 240 grams of O2 is reacted? Okay, so theoretical yield just means how many grams will be produced. So we're looking for X grams of H2O. Okay, and we have 240 grams of O2. So we're going to set that equal to the grams of H2O, right? And that is 72.08 over the grams of O2, which is simply 160.0. When we solve for X here, we're going to get 160.0 times X equals 72.08 times 240. And when I solve for X, I get 10.8 grams of H2O. Okay, so we just solve for X the same way we always do. Theoretical yield is not scary. It is simply the number of grams that would be produced. Okay, so that's pretty much the method of stoichiometry called the ratio method or the proportional method. And it's a good alternative to the dimensional analysis method. If you have any questions, feel free to email me.